Hello everyone. Yeah. So this is the final that is the eighth lecture of that course, engineering economics course. In today's lecture, we will, as we have studied all the things, like the topics that we have covered are uh, till now are like first we have covered the introduction and the basic engineering economics, and followed by the interest rates and the value the time value of money and the value of money and the different time frames. Then we have done the depreciation. What is the depreciation? How we have calculated this, and what's its importance. Then in the other lecture we have done the cash flows and the life cycle cost. And we have also covered the financing part, the various financing terms and the financing measures. What uh, what are the things related to that? Then we have done the sensitivity and the risk analysis. And the recent lecture that we have done is decision making and buyer. I mean, how to make a buyer make. I mean, should we make the product or we should just buy it from that outsourcing. So in today's lecture, we will study the elementary economic analysis, in which we will use all the things that we have studied, and we will do an elementary economic analysis with some quite examples and case studies. Basically, starting from that from the lecture, starting with an introduction part. So from the introduction, interest, just a minute. So introduction, whether it is a business situation or a day-to-day event in somebody's personal life, there are large number of economic decisions making involved. So one can manage many of these decision problem by using simple economic analysis that we have already seen. For example, an industry can source its raw material from nearby or for a far from place. So there are options available, like cheapest cost available and the cheapest transportation available. Then we have to consider what option should we choose. So the factors affect the factors that will affect that decision will be price of raw material, transportation cost of raw material, and availability of the raw material, and of course the quality of the raw material. So these are the factors that will affect the decision. Now, the alternative source of raw material, we are having two options. One is the nearby and one is the far from place. So let's consider first the nearby place. So the alternative source of raw material from the nearby place will start with the raw material is more costly in the nearby area. The availability of raw material is not sufficient enough to support the operation of the industrial throughout the year, and the raw material require pre-processing before it is used in the production process. This would certainly add an extra cost in the product. And finally, the cost of transportation is minimum in this center. This is the positive point in this option available. Let's see another option, that is mm, alternative of sourcing raw material far from place. So in that case, the raw material is less costly at a far place. The cost of transportation is very high, that is a negative point, and the availability of raw material at this site is abundant and it can support the plant throughout the year. The raw material from this site does not require pre-processing before using it for production. So these are some factors, alternative that are available for the far place and the nearby places. So now let's under such situations, the The procurement of raw materials should be decided in such a way that overall cost is minimized. So we will calculate the overall cost, and what should be the option that we should choose. Then we will study this. Like example, for the simple economic analysis, there are 4 to 5 options that is available. One is the material selection for a process, design selection for a product, design selection for a process industry, building material selection for the construction activity, and the process planning or the process modification. So these are the options available. Mm, so we will solve. We will see one by one each. So starting with the material selection for a product, or we can say substitution of raw material. So in this, the cost of product can be reduced greatly by the substitution of the raw material. Suppose we are having some cheap raw material that is available, so the overall cost of the product can be reduced drastically. Among various elements of the cost, raw material cost is the most significant, and it's it forms a major portion of the total cost of any product. So any attempt to find a suitable raw material will bring a reduction in the cost any one or combination of the following ways. So these are the ways in which we can reduce the total cost by reducing the raw material cost. One of them is cheaper raw material price, reduce machining or process time. Some material needs pre-processing and the post-processing, so that will reduce. Suppose we are using a low quality of coal, then we have to use a uh, flue gas flue gas analyzers and the for the lower pollution, some pollution control equipment in the power plant. So that will add a post processing cost in that power plant, and enhance the durability of the product. If you are using a most durable product, then we do not need to change the product time to time. The only single product can work for a longer time, so that will be come under the durability. Now, therefore, the process of raw material selection and the substitution will result in the finding of an alternative raw material. Let's see an example. In the design of a jet engine part, the designer has a choice of specifying either an aluminum alloy casting or a steel casting. Uh, Either material will provide equal service, but the aluminum casting will weigh 1.2 kg as compared with the 1.35 kg for the steel casting. Now we have two options. One is the aluminum casing and second is the steel casing. Now the aluminum can be cast for 80 rupees per kg and the steel can be cast for the 35 rupees per kg. The cost of machining per unit is 150 rupees for aluminum and 170 rupees for steel. Every kilogram of excess weight is associated with a penalty of 1300 due to an increased fuel consumption. That is a per kg. So which material should we specify and what it is the economic advantage of the selection per unit? Now let's see. Let's solve this. First, we will calculate the cost of using aluminum metal. Here in this weight will be 1.2 kg. Cost of casting is 80 rupees per kg. Cost of machining will be 150 rupees. So the total cost will be cost of aluminum casting plus cost of machining. That will be 80 into 1.2 plus 150 rupees. That will be at a 246 rupees. So that is the total cost. Now let's do the same thing for the steel casting. Cost of in this case also the weight is given. The weight that is given is 1.35 kg. Cost of casting is cheaper, that is 35 rupees per kg. And machining cost is 170 rupees. Now if you want to calculate the total cost, the total cost will be similarly 35 into 1.35 plus 170. But here that one more thing will be added to the total cost, will be the penalty of for excess weight of steel casting, because we are seeing that. So that will be 35 into 1.35 plus 170. And how much weight is more? That is 1300. That is the weight of the steel casting is 1.35 kg, and the weight of aluminum is 1.2 kg. The remaining 150 grams that we are carrying extra, that will add extra cost. The total cost will be 412.25 rupees in case of steel. Now, decision. What decision should we make? The total cost for aluminum is less than the total cost of steel. Hence, aluminum is suggested for making the jet engine part. The economic advantage using the aluminum over the steel will have. What is the economic advantage? Now let's calculate the economic. Advantage will be 412.25 minus 246. That is rupees 166.25 per unit. So in that way we will see, we have seen that aluminum is more cheaper and economically viable. Let's see in another example. A company manufactures dining table with mainly consist of wooden frames and tabletops. The different material used to manufacture tables and their cost is given as below. So description of item: wood for frame and legs, a tabletop with a sun mica finish, leg bushes, nails, total labor quantity is 0.1 meter cube, 1 400 grams, 15 hours. Cost is given here. In view of the growing awareness towards deforestation and environment conservation, the company feels that the use of wood should be minimal, and the wooden top, therefore, could be replaced with a granite top. So this is an environmental factor that we are considering. Now, this would require additional wood for the frame and the legs to take the extra weight, because this wood is lighter and the granite is heavier. So that would add an extra cost, extra wood. Now, the material and labor requirement along with the cost details to manufacture a table with granite top are given as below. So these are the additional thing that we need, like the data for this, like wood for the frame. Now it will be required as 0.15 uh, granite tabletop, 1.62 meter, leg bushes 4. Here the leg bushes are also 4, and the nails are 50 grams. Total labor of 8 hours. If now what they're saying, if the cost of dining table with a granite top works out to be lesser than the table with a wooden top, the company is willing to manufacture dining table with the granite tops. Compute the cost of manufacturing of a table under each alternative described above and suggest the best alternative. Also, find the economic advantage. Now this is a broader application of the economic analysis. So we should calculate this. Let's start this. First, we will start with cost of table with wooden top. Wooden top, or we can say that is a base case. So let's calculate cost of wooden frame is 1200 into 0.1, that is final cost will be 1200. Cost of wooden top will be 3000. Cost of bushes is 10 into 4, that is 40 rupees. Cost of nails is 300 into 100 upon 1000, that is 30 rupees. Cost of labor is 500 into 15, that is 750 rupees. So the total cost, if you will add up this all thing, that will comes out to be 5020 rupees for this. Now let's calculate the similar thing for the granite top. Here similarly, the cost of wood for frame will be 12,000 into 0.5 or 15, that will be 1800 rupees. Cost of granite top 800 into 1.62, that is 1296 rupees. Cost of push list is 25 into 4, that is 100 rupees. Cost of nails is 300 into 50 upon 1000. And finally, cost of labor, that is 50 into 8, that is 400 rupees. So if you will add the total cost would be 3611 rupees. So we have seen that total cost is less than the wooden table, and also it's environment friendly. So here the total cost of table with the granite top works out to be less than that of the table with the wooden top. Hence, the table with the granite top should be selected for the manufacturer. Now our decision: total cost of wooden table is more than the total cost of granite based table. So of course this should be chosen. Suggested. Now what is the economic advantage? Economic advantage is total cost of wooden minus total cost of granite, that will be 5020 minus 3611 rupees, that is 1409. So that is our economic advantage per unit. Now let's move on to the our second application, that is a design selection for a product. In this, the design modification of a product may result in the reduced raw material requirement or increased machinability of material and the reduced labor. So that can also reduce the overall cost. Design is an important factor which decide the cost of product for a specified level of performance of the product. The elementary economic analysis that we are doing is applied to the selection of the design for a product is illustrated with the two examples problems. Now let's start with example 1. Two alternatives are under consideration. Now we have two alternatives are under consideration for the tapered fastening pin. Either design will serve the purpose will involve the same material and manufacturing costs expect for the lathe and the grinder operation. Now for design A will require 16 hours of lathe time, 4.5 hours of grinder time and 1000 units. And design B will require 7 hours of lathe time and 12 hours of grinding time per 1000 units. So the operating cost for the lathe including labor is given as 200 rupees per hour. Now the operating cost for the grinder including labor is 150 rupees per hour, which now we have to decide which design should be adopted for 1 lakh units to be produced per year, and what is the economic advantage for the best alternative. Let's solve this. Operating cost for lathe is given 200, and operating cost of grinder is given 150. So let's start with the case 1. Cost of design A. Number of hours of lathe required is 16 hours, and number of hours for the grinder is 4.5 hours. This both will be for the 1000 units. So the total cost will be 16 into 200. Let me just so the total cost will be cost of lathe plus cost of grinding operation. So that will be the cost of lathe will be calculated as 16 hours, and the cost of lathe is 20 rupees, 2000 rupees per hour. And similarly for the grinding, that is will be 4.5 multiplied by 150. The total cost will be 3875 rupees. So here we have to make 1 lakh products for 1 lakh units. That will be 3875 into 1 lakh divided by 1000, because this is the cost for 1000 units. Now that will be around 3,87,500 rupees. Similarly, if we will calculate for case B, a design B, and then the lathe hours is given as 7 hours, and the grinding hours is given as 12 hours. Now we can calculate the total cost. That will be cost 700 into 7 into 200 plus 12 into 150. That will be 3200 for 1000 units. And for 1 lakh units, total cost will be 3,22,000 rupees. And that is in a similar way, 3200 into 1 lakh upon 1000, that will be finally this much. Now finally, what is the decision? The total cost of design A is higher than the total cost of design B. Design B is recommended. Now let's calculate the economic advantage. Economic advantage will be 3,87,500 rupees. That is total cost of from design A and divide minus total cost of design B. So economic advantage will be 67,500 rupees per 1 lakh units. So this is the example of a design basis that we have done, design selection for a product. Now let's move on to the next thing, that is a building material selection. As discussed in the introduction of this lecture, the sourcing of raw material, sorry, the source, the sourcing of raw material will have a significant effect on the cost of any product. Hence, it is assumed that the price of raw material is location dependent, while the sourcing a raw material, the cost of transportation to be considered in conjunction with the price of the raw material. This concept is demonstrated with a numerical example. Let's see this. So here in an example, the design of buildings to be constructed in the alpha state. The designer of this considering the type of window frame to specify either steel or aluminum window frame will be satisfy the design criteria because of the remote location of the building site and the lack of building material in the alpha state. Now the window frames will be purchased in beta state and transported for a distance of 2500 km in the site. The price of window frames of the type required is 1000 each for the steel frame and the 15,000 each for 1500 each for aluminum frames. The weight of steel window is 75 kg and the aluminum is 28 kg. The shipping rate is 1 rupees per kg per 100 kilometers. Which design, now we have to decide which design should be specified and what economic advantage of that selection. So let's solve for this. Here distance between alpha and beta state is 2500 kilometers and transportation cost is 1 rupees per kg per 100 kilometers. Let's choose a case one, that is steel frame. Price is 1000 and weight is 75 kg. So the total cost will be based on the price plus transportation cost. That will be 1000 rupees plus 75 into 2500 divided by 100. That is because of per 100 kilometers. So the total cost will be 2875 rupees. Similarly, for the aluminum frame, if we calculate, then the price is given is 1500 rupees weight is 28 kg. So the total cost will be 1500 plus 28 plus 2500 divided by 100. That will be around 2200 rupees. That was for steel. So now what should be our decision? Decision is total cost of steel was more than the total cost of aluminum. Hence the aluminum window is recommended. Now what should be the economic advantage? Economic advantage will be 2875 minus 2200. That was for the steel minus aluminum. So 675 rupees per unit. So that's how we can calculate the best case that we can choose in a building material selection. Now let's move to the process planning or the process modification. So this is the final thing that we are going to start: process planning and the process modification. We have already seen material selection, design selection, and the building material selection. Now we can see the process planning or the process modification. While planning for a new component, a feasible sequence of operation with least cost of processing is to be considered. This is the one of the major conditions that we should apply. The process sequence of a component which has been planned in the past is not static. It may change, and it is always subject to modification with view of minimize the cost of manufacturing of the component. So the objective of process planning or the process modification is to identify the most economical sequence operation to produce the. Now we can arrange the different kind of sequences for the process in the way to minimize the cost. So there will be some steps involved in the process. These steps in the process planning are as below. First, analyze the part drawing to get an overall picture of what is required. First, we have to analyze the part drawing. Second is the make recommendation to or consult the project engineer or the product design changes. Make recommendation to the project engineers. Third thing is the list the basic operation required to process the part to the drawing or the specification. List the basic operations required. Fourth one is the determine the most practical and economical manufacturing method, and then the form of tooling required for each operation. We have to then we can uh, form the tooling required for the each operation. The fifth one is the devise the best way to combine the operation and put them in sequence. Combine the operation and put them in the sequence. And the final one is the specify the gauging required for the process. So let's see this with an example to get some more clarity. Here, the process planning engineer of a firm listed the sequence of operation shown in the table 2.2 in the table below to produce a component. Here, the process sequence is sequence 1, turning, milling, shaping, drilling. Or other one is the turning, milling, drilling, and the all operation are performed with a CNC machine. That is computer numeric control machines. Now, the details of processing time of component with the various operation and their machine hour rates are summarized in this table. Turning operation is costed as a 200 rupees and the process sequence is 5. Here this is the process sequence and this is the processing time that is given in minutes. Similarly for the milling, shaping, drilling, CNC operation that is given. Now we have to find the most economical sequence of operation to manufacture the component. So we will try the various iterations for that. Let's first start with the cost of component using sequence 1. The process sequence 1 is given turning followed by milling followed by shaping followed by drilling, and the calculation for the cost of the above process we can calculate like from operation number, operation time, machine hour, and the cost. Now we will calculate each of the thing. First one is the operation number. Should specify. First one is turning, milling, shaping, and drilling. So the turning operation time was given for the 5 minutes, and if you will convert them into the hour, that is in the minute and that is in the hour. 0.083, machine rate is 200, overall cost is 16.60. That conversion for the minute to hour is needed for that, because that machining cost is given in the per hour format. Similarly, for the milling it is given 8. If we convert them, that is 1.33, and 400 rupees per hour finally will be 53.20. For the shaping it is 0.167 hour multiplied by 350, finally we will get 58.45, and the drilling will be 0.050 into 300, finally 15 that we got. The total time, if we will add all of this, we will get 143 rupees 25, 143.25 rupees. So now let's take another example of cost of component using sequence 2. So we have given two sequences. Now the second sequence was given as turning followed by milling followed by drilling. Now let's make some calculation for this case also, like operation number, operation time, machine per hour, machining cost, and the finally cost. So in a similar manner, if I will see, then there will be three processes. One is the turning, milling, and drilling. The time in minutes is given 5, 14, and 3. If you will convert them into the hours, that will be 0.8083, 0.233, and 0.050. Machining rate is given. Machining rate per hour is given 200, 400, and 300 for the turning, milling, and drilling respectively. The cost, if you will calculate, then this multiplied by this will be 16.60, 93.20, and 15 rupees. And overall, if you will calculate, total will be 124.80. Now, finally, the third option that we have available, that is the cost of component using process sequence 3. Here we are having only CNC operation. Now, if you will calculate, we can simply calculate that time given is 8 minutes, and 8 minutes, if you convert it into hour, will be 0.133 hour, and the machine rate per hour is given as 1000 rupees, and that's for the overall cost. Total cost we can calculate directly from 1000 into 0.133. Finally, we will get 133 rupees. And if we will compare that cost, all three sequences, all three sequence, or then we will see total cost of sequence 1, total cost of sequence 2, and total cost of sequence 3 will be, that is 133, that was 124.80, and for the process 1 we have got 143.25. So that was the minimum. Therefore, what should be our decision? Sequence 2 should be followed for manufacturing the component. So in that way, we can decide for the different examples that we have studied. So the final cost that we have got, that is that's all for that all the things that we have studied. If you want some more insights on that lecture, you can contact me also, and also we can you can read these basic 3 or 4 books you can read. That one is much recommended because that is a very simple language and some Indian context is there. If you want to really feel the things, how the things works, the basic level book is the Engineering Economics by the PHI Learning Private Limited, by R. Pannesevalam. You can read this, and if you have anything remaining, then you can add into the comments, or you can add in the Google Classroom. I will clear them all. So that's all. Thank you.